Yeah, welcome to the Hive Research Institute of Technology. My name is Yakub Mohammed. In this video, I'll be showing us how we can compile our project file for the EGS proMAX using the XTM version. So I'll just show you how it can be compiled. I already have the project folder on my desktop. This is the project folder for the ECG proMAX 002. So these are the project files inside the proMAX folder. So I'll just close it. So the program was actually compiled using the IDE for XTM32 Cube. So I'll just start the program, and let's just wait for it to load. Okay. So if you have fully installed the STM32 Cube IDE software, this is how it should look like. I'm not going to be teaching us this software. I'm just going to show us how you can compile the project folder, the project files for the EGS002 proMAX, the XM version. So once you have the software fully installed and it's up, you should get something on your screen that looks similar to this interface. Okay, I will go to File, go to Open Project from File System. So I'll go to the directory. I think our project folder is actually on desktop, so I'll click on directly and look for it. I think it's here already. proMAX. Okay, I'll just click on the folder. Once I click on the folder, so actually on my desktop, so this is the file path to the project. I can select the file, the folder, just select the folder. Okay, once that is done, you'll notice that the folder has been selected as a EGX proMAX, and of course the path is on my desktop. Then I'll click on finish. Okay, so you see that the project folder has actually been loaded. The project has actually been loaded to our system. So I'll just click. I can click this to drop down the menus. Then what am I looking for? I'm looking for the C project code. We have the core, we have drivers, we have debug. Drivers is actually the internal drivers that the XTM uses. So I'll just ignore that for now. We'll go to core. We'll go to the SRC folder. So this is actually the main C program. I'll just click it. Okay, this is the C program. So this is the program here. So before I go forward, I want to show something. Okay, I want to show something. So as you can see, I've included, these are user code. I've included a file called util.h. I've included a file called modebus.h. I've included a file called psm004t.h. And all these files are actually located where? On my C drive / STM32lib. So if you don't have this, the program might not run. So you need to download it on my website. Once you download, you can drop that at whatever part you want them. But it's safer to have them. Let's just look for coming. Let me go to this project. My C drive. I'll just go back. I want to go to my C drive. Okay, this is my C drive. So this is the file path, STM32lib. So you need to copy this and put on your C drive, so that your project can see it. If you don't have it, it's actually on my site. You can download it. I think the last update I did, I included this inside the ECG folder that I uploaded. So, but if you can't get that on that directory, then just go to the site directly and copy it. Okay. So it's here, and although I have many other files inside of my own, but the one I'm sending to you, I only put the files actually necessary, which is the util.h, which is the psm004t, and of course the modebus LCD. So if you have those files in those directory, you are good to go. So the next thing, we just go to project. You build all projects. So like as you can see, you have the 0 errors, 0 warning. Let's just create an imaginary error, or just create an error. So this is an error. Let's compile and see. Project build all. I like to use build all because of all the folders, all the files that are attached. So I don't need to be manually building them one at a time. Okay, so you can see that we're getting how many errors? 6 errors, just because of what the error we added intentionally. So I'll just take it back. Okay, you can compile project build all. Okay, 0 errors and 0 warning. So that is all you need to compile. If you need to make any adjustment to the code, you can do that from the C project. Other important files are actually here, which is the HAL MPS. This is added by default. You have the interrupt routines that are added by default. We'll just go to the interrupt routine. At some point you might want to adjust that. I think on the interrupt routine, the only thing we did, just look at what we did on interrupt routine. There are so many interrupts that I'm not using. Okay, the 6 tick is by default. Okay, the timer up. This is a code we added. This is where we update our PWM for charging. So each time we calculate the PWM necessary to generate the actual voltage or current that we need. This is where it's been updated. On T1 up. So we have the T1 compare. We're not doing anything to compare. We're only using the overflow to update the value we have calculated for the new PWM for charging. Okay, we use T2 for the zero cross detector, and of course we use the interrupt 13 pin 13 for the what. We use both timers. So the interrupt pin is actually used to detect the falling and the rising edge of your zero crossing, while T2 is actually used for the overflow. So each time, as long as there is light, the interrupt will be called, and as long as the interrupt is being called, T2 will never overflow. T2 can only overflow when the interrupt stop working, and interrupt will only stop working when there is no light. So it takes a minimum of 10 to 11 milliseconds for this to be called. Of course, that is more like half of your 50 Hz. So these are, at some point, you might, if you need to, you might want to make some adjustment to them. How fast you want that to be called, or of course how slow you want it to be called. Aside that, we'll go to only the C file, where you need to make your adjustment as the case may be. Okay, that is done. So like I said, you just click on the project build all, and your binary file is created. Now remember that in STM, it doesn't work on hex alone. You can use binary or hex. I prefer to use binary. I think when I was programming 8051, when I was programming PIC or EVR, what they are concerned is just your hex file. But for XTM, you can either use the hex file and the binary, or the binary file, not the both. So in my own case, I'm using the binary file. So I'll just click on the program to download, to transfer our hex to our STM. So I like to, okay, let me just look at the file erasing. So I like to let's go to that file part. What I normally do, I'll just go to file part. I will remove the hex or binary file, I'll delete, then I'll go back and recompile. Most times I prefer to do this, or probably I like doing this to ensure that I have the recent binary file, so I don't program the wrong binary file into my code. So I'll just program. So I'll go back to it, click. Okay, so that the binary file is there. So the essence of this is just to show us that, okay, the compilation I did, I have the recent binary file, because there are times I'll be making changes, I'll be updating, and my binary files are not being updated. I might be programming the wrong binary file, and it will just cause me a whole lot of stress trying to figure out what the problem is, or probably what is actually going on. So like I said, one of my best options is that each time I want to generate my binary file, I delete the previous one manually and generate, so that I am sure that whatever binary file I have is the most recent one that I want to use. I think in a separate video, I already showed us how we can actually use this program to transfer our code, so I will skip that process. If you want to see how your binary file can be transferred to your to your STM, whether it's the proMAX you're using, whether it's any version of STM. I have a video, a separate video where you can go and actually watch and see how that is being done. I hope this video helps. Once again, thank you for taking your time to watch our video, and I will always appeal to you to hit our subscribe button, or probably hit the like button to encourage us to do more videos on this. Thank you.